Hello all, welcome to the video lecture on Big Data Analytics. In our earlier classes, we have discussed about the different types of Big Data Analytics, and we started with the descriptive analytics where we discussed about the basics of descriptive statistics, probability, random variable, and probability distributions. While talking about the random variables, the random variable is a variable whose value are numerical outcomes of random phenomena, and we saw there are two types of random variables. One is the discrete random variables and another one is the continuous random variables. And the discrete random variable is one which may take on only countable number of distinct values such as 0, 1 and 2. And if random variable can take only finite number of distinct values, then it must be discrete. And we also discussed about the probability distribution of the discrete random variable. It is nothing but a list of the probabilities associated with each of its possible values. So we call it the probability mass function. And for discrete random variable, and the probability distribution function for the random variable is the variable which describes how the probabilities are distributed over the values of the random variable. So um, we'll be discussing about the special probability distributions, and we will start with the Bernal distribution. This Bernal distribution deals with an event or associated with an event when we have only one trial and two possible outcomes. This probability distribution, this Bernal distribution, has only two possible outcomes and single trial. This trial is called the Bernoulli trial, and we express the distribution as a variable x, this capital X, which follows the Bernoulli distribution with the probability of the success equal to p. This small p represents the probability of the success. And we will see an example. Suppose we toss a fair coin once. What is the probability distribution? And we'll see what's the probability distribution of the number of heads in that single toss. Well, it's gonna have the Bernal distribution because we have single toss or single trial, and we have possible two outcomes. One is the head and another one is the tail, and in this toss we will see the probability distribution of the number of heads in the single toss. So we have a single trial where each trial can result in one of the two possible mutually exclusive outcomes, and we gonna label those two outcomes as a success and the failure. And the probability of success on that trial is going to be represented by small p, this small p, and the probability of failure, p of failure, is equal to 1 minus p. And if the conditions hold, then x has what we call the Bernal distributions, where the probability that the random variable x, this capital X, takes on the value of the small value equal to, you can see here we have the Bernal distributions. Here the probability that the random variable x, this random variable x, takes on the value of the small x uh, is equal to p, and this little x is equal to p to the power x and 1 minus p and 1 minus x, and sometimes we just say p of x, this p of small x. And now we should do is say what the value x can take, what the value x can take on. So we can write here the for little x being equal to 0 and 1, and uh, for all of these we refer it sometimes as the probability mass functions of the Bernoulli distributions. And if we write this out for the individual values, then we would see that probability that random variable this small x takes value 1 is equal to px equal to 1 is equal to p to the power 1 minus p 1 minus 1. Then it will result into this only p, this is small p. And for and the probability that the random variable x takes on 0, this would be equal to px is equal to 0. This means the probability this is the random variable that x takes on 0 is equal to p to the power 0 1 minus p 1 minus 0 means 1 minus p. So these are the probability of this gives the first with x is equal to 1 gives us the probability of success, which is p, and the probability of failure, this is the 1 minus p. Now we will see a simple example. Suppose we have a box of bulbs where approximately 1 in 200 bulbs in this box are defective, and one bulb is randomly selected, and we will see what is the distribution of number of defective bulbs. So we in this distribution in this scenario we will see the probability distribution of the number of defective bulbs. So we have got the single trial, and each bulb is defective or not, and the condition for the Bernoulli distribution here is satisfied because we are going to take the we are going to have the single trial, and we will have the two outcomes whether it's defective or not. So the number of defective bulbs is going to have the Bernoulli distribution with the parameter p, this p, and p is going to simply the probability that any single bulb is defective, which is about 1 divided by 200. And if we let the random variable x, this random variable x represent the number of defective in our sample of the size 1, then the probability that the random variable x takes on this little x is going to equal to p to the power x 1 minus p to the power 1 minus x, and here our p is 1 by 200, which is 1 over 200 to the power x times 1 minus p, and we which is 1 minus 1 by 200 to 1 to the power x, and this is for x equal to equaling 0 or 1, and because we are going to take one defective or not, and substituting these values here, we substitute this value, and we see the probability that we to get the defective is going to be equal to 1 by 200, and the probability that we don't get the defective bulb is going to simply once we calculate this, and we will get the value 0.0995. so this gives us the simple Bernoulli distribution of the of our bulbs, like this gives the distribution of the number of defective bulbs.